Okay, so in the previous section of our notebook, we had an expression, a Mathematica expression, which took the first part of the book Alice in Wonderland and counted the frequency of each of the words that appeared in that section. Here's another bit of code, another Mathematica expression that will let us experiment with techniques of reading code. So, as before, what I'm going to do is I'm going to highlight the cell bracket on the right hand side to choose that cell, and then I'm going to hold down Shift and hit Enter or Return to evaluate the expression. And what we see here is we see that the Mathematica expression that we just evaluated has output a list of words in alphabetical order, A across, actually, and so on, all the way down to would. Now, when we look at this code, when we try to read it, we notice that in fact it has some code in common with the expression that we just used. If we start here, I'm just going to highlight it. If I start at word counts, actually, let me just click behind word counts so I can see the enclosing bracket in green. I'm going to highlight from that bracket to the beginning of word counts. There we go. The section that I've highlighted in blue here is the section that was part of the code that we just looked at, part of the expression that we just looked at. Starting from the inside and working out, the example data command retrieved a string of the text of the book Alice in Wonderland. Click on that. Then we used the string take command to take the first 1003 characters of that book as a smaller string. And then we used the word counts command to count the words that occurred in that section of the book, and it gave us our word frequency information. This command here, this expression, has a number of other commands wrapped around it that somehow create this behavior that we see here. Now, if we just look at this, and try to figure out what is happening, we can see that it appears to be a list of words, and we might hypothesize that that list includes all of the words that occur in that first section. So let's just use our string take command here. I'm going to copy this out as we learned last time. Command C or Control C to copy, Command V or Control V to paste, and then Shift and Enter to evaluate. Here is the text that we're working with. If we look here, we can see down the rabbit hole, Alice was beginning to get very tired of sitting by her sister on the bank. Well, we can look up some of these words. Was is in there, beginning, to, get, very tired, and so on. So we can hypothesize that this is a list of words that occur in that first passage. But notice that Alice is not in there, and that down and rabbit hole are not in there either. So down the rabbit hole and Alice are not in this list here. So another hypothesis would be that it's not all of the words, it's just the words that are in lowercase. And if we look into the passage, we see that the passage includes the white rabbit with capital letters, and the word white is not in this list, and the word rabbit is in this list because it appears in lowercase down here at the end of this paragraph. Now, when we're investigating code like this, it's convenient not to have to copy the entire passage, the entire expression, if we want to keep working with it. Sometimes we would like to be able to give something a name and then just refer to that name. And the way that we do that in Mathematica is with commands set, and then if we want to get rid of something that we've set, we can use the command clear. Notice that this word text is in blue. If I choose that cell and click Shift and Enter to evaluate it, it just returns the word itself. Now the set command takes two arguments. These are the things that come inside the square brackets and they're separated by a comma, we can say set text, and then we've got this string, this is a test. If I evaluate that cell, it outputs this is a test. But notice now that the word text has changed from blue to black here and up here and down below. Now if we choose text and we shift and enter to evaluate it, it outputs this is a test. So what's happened is we've taken this value here, this string, and we've assigned it to this word. In Mathematica, that word is called a symbol. We've used the set command to set a symbol equal to a particular value. If I want to get rid of that setting, I use the clear command. So I say clear, put text inside the square brackets, go shift enter. Now it has turned blue again. If I go back and evaluate this blue version of it, it just returns text because it has nothing else assigned to that symbol. So what this lets us do is it lets us take an expression of arbitrary complexity and assign it to a symbol, and then we can refer to that big expression by using its name instead of by using the whole expression. So where would we use this? Well, suppose, for example, we want to refer to the first 1003 characters of the text Alice in Wonderland. We want to refer to this string. We can use text on the left hand. We want to make sure that it's blue and make sure that it starts with a lowercase letter. Equal sign is the shorthand way to refer to the set command, and then whatever expression it is we want to assign to that. So if I hold down shift and I press enter, text now turns black, and it now contains this whole string here. Now I'm able to use that symbol instead of the whole expression. So for example, if I say word counts of text and hit shift enter, it gives me the counts for all of the words. And here we notice the occurs 10 times, her occurs 7 times. This is what we discovered with the last section. Alice occurs 4 times, capitalized. Rabbit occurs 3 times, capitalized, and so on. And we can continue to build expressions around this symbol now instead of the whole section of code that has been assigned to it. So I could ask for the 15 largest. This is equivalent to the expression we computed in the previous section. Now that I have this expression here, word counts of text, I can substitute it back in to the expression that we started with up here. So this is the expression we're trying to analyze, and this whole bit inside here, from this word counts to its enclosing square bracket, I'm just going to highlight that. This whole expression is equivalent now to the symbol text. So moving back down here, this expression gives us the same output as the one that we started with, because we've used text to refer to all of that stuff that was inside there. Now, in order to understand how things work, we've been studying some strategies for doing that. One of the things that's very important when you're first learning how to program, and even after you've been programming for many years, is before you actually evaluate code, you want to stop and ask yourself, what is this going to do? And you want to make a hypothesis. And if you run the code and what you predicted comes true, then comes out the way you expected, then you can say to yourself, okay, I think I understand that. But if it doesn't come out the way you expected, then you can stop and ask yourself, what is happening here that I didn't quite understand? So for example, what's going to happen when I evaluate word counts of text? Well, we already know that it's going to go through and create that output representation that shows how many times each word occurs, sorted in such a way that the one that occurs most frequently, the, is listed first, and then her and of, and so on. So that's what that expression does. But what does this expression do here? Well, we know if we go back up and we look at the output here, we can see that whatever this whole expression does, one of the things that happens is that the number that's associated with each of these words disappears. So we might hypothesize, and this would be correct, that this is going to give us the things on the left-hand side of each of these arrows, but not the things on the right-hand side. Let's evaluate and check and see. So this returns the words to us in the order that they appear in word counts, but it gets rid of the arrow and the number associated with each word. So the, her, of, and. So we have the same words in the same order, but we've lost the information about counting. That's what the keys command does. Now, it's also the case that there's a command called values, and I'm just going to evaluate it. What values does is it takes this expression here and it returns just the numbers. So 10, 7, 7, 6, 5, 10, 7, 7, 6, 5, and so on. So the keys command and the values command are a pair of commands that take this kind of an expression, this is called an association, that take an association and they return either the left-hand side of each of these parts or the right-hand side of each of those parts. Here's another command that we can look at. Let's try to predict what this will do. We see first of all that there is a list, includes down, capitalized, entirely uppercase, Alice, capitalized, and beginning in lowercase. So this list is one of the things that we're giving to the select command. The other thing that we're giving to the select command is this command that says lowercase q. If I evaluate it, it shows us that there's only one thing in this list that is in lowercase, and that's the word beginning. Alice is capitalized, and down is all uppercase. Now that we know what this expression does, we can compare it with this next expression, and we can say, well, what will the next expression return? It's not going to return beginning, because we know beginning is in lowercase. It's going to return down, that's in uppercase. Is it going to return return Alice, because that's capitalized? Not sure until we try it. Just returns down. So lowercase gives us things that are all lowercase. Uppercase gives us things that are all uppercase. Now in Mathematica, there's more than one way to do something. That's really true in Mathematica. It's often true in other programming languages also. We've explored a couple of commands that allow us to do things with word frequencies of a text. It would be nice, for example, if we were also able to pull out a particular word to get its word frequency, and that's what this expression here does. So I'm going to hit Shift and Enter to evaluate it. We already know what word counts of text gives us, but I will do it up here just to be explicit. Word counts of text returns this association. This next command lets us ask for the count for a particular word in the association. What happens if we try to count the number of times that the word pink appears? One time. What about the word key? I'm going to copy and modify. This gives us an error message. It tells us that the word key does not appear in this association. So Alice occurs 4 times, capitalized. Pink, lowercase, occurs 1 time. Key doesn't occur at all. It says missing, key absent, the word key. Now the frequency of a word is simply the number of times that that word appears divided by the total number of words in a text. If we want to figure out how many words there are in the text, we can take this list of values that we created up here, 10 copies of the, 7 copies of her, 7 copies of, and so on. If we were to add together all the numbers in this list, that would tell us all of the total number of words that occur in that expression. And we can do that like this. So word counts of text gives us the word counts. Values takes the right-hand side of each one of those things in the association, the count, and total just totals them up. Now a different way to do this would be to take the list of words in the text and calculate the length of that list. It tells us that the list has 192 things in it, which is just another way of counting the total number of words. Either way we do that calculation, we know that Alice occurs 4 times out of a total of 192. Let's evaluate that. It gives us a fraction. Mathematica always keeps fractions, which is nice if you're working with fractions, but in this kind of application we usually want to see a decimal number, and we can do that by wrapping the whole expression with a capital N, which gives us 0.02. So that's the frequency with which Alice occurs in this section of the text. And finally, there's even a command called word frequency. We can say in the text, how many times does this word occur? Shift Enter, and it gives us exactly the same result, which is good, because if it didn't, we would be concerned.